Hi there, how you doing? I would like to solve this problem using a video and actually the whiteboard of Wyzant because this problem involves area and it's better to show it also graphically, which is not can be done on other platform. So that's why I'm recording this video. Anyway, in this problem, you've got to find an area between a curve, which r equal 3 plus 3 sine theta and r equals 3. R equals 3. So what are these two curves? This r 3 plus 3 sine theta is actually a polar form of a curve, and r equals 3 is actually also a polar form of a curve. Well, it's actually a circle with a radius of 3 units. So you can draw this on a graph like that. We call this the x coordinate, and this is a y axis. Okay, x axis, y axis. Okay, so what is r equal 3? Well, r equal 3, like I said, it's a radius of 3, a circle of radius 3. So if we draw a circle with a radius of 3, see if we can draw that circle in the most efficient manner. And sometimes it's hard to find the center of that circle. Here. So just basically correct this like that. So this is a curve of r equals 3. It has a radius of 3 units. So this is plus 3 here, and this is minus 3. And so also really plus 3 and minus 3. Okay. So that is a curve r equals 3. And what is r 3 plus 3 sine theta? Well, 3 plus 3 sine theta is a cardioid. And I'll show you how to draw that cardioid. Okay. So this is like of the form r equal a plus b sine theta. Okay. So here a will be 3 and b will be 3. So this tells me immediately that this cardioid has limits of a value. This is a value of equal 3 units. Therefore, it passes through this point. also it passes through this point. And if we take A over B, so how do we draw this? Well, we take A over B equal to 1.0. This means that A minus B is equal 0. Equal to 3 minus 3 equal to 0, which means that the cardioid also will pass through this point. And also A plus B equal to 6. So the uppermost part of the cardioid is a point here. I'm going to call that point here, I'm going to call it 6 plus 6. So why is it plus? Because it's a sine theta. Sine theta, that means it's a cardioid that opens upwards. Okay, so if we are to draw this cardioid that opens upward, it will be something like that. Something like that. And closes in at 6 here. Closes in at 6. Let me fix this better. That's a better cardioid. Okay. So the because it is P sine theta, so it opens up and it intersects the y-axis at the plus 6 here, and intersects the x-axis at minus 3 and 3. So in this problem, you're asked to find the common area between the two curves. So the common area between the two curves is the intersection of the two curves. Let me draw that intersection in green color so you can see where that intersection is. It's actually this area bounded here. And we're asked to find, so if I am to make this area look, so this is the area that bear with me a second here. So this is the area where I'm supposed to find, I'm going to draw that in blue. That's the one I'm tracing right now. Is a common area that you need to find the area for. That's what the problem is asking you. So it's this here, this shaded area in green. Okay, just make my point right. Something like that. So this area involves at least half of the circle area of the small one, right? So what's the area of the small circle? It's the area of the small circle is equal to pi r squared. So it's equal to pi times 3 squared equal to 9 pi. So 9 pi 9 pi. Okay. That's the area of the black circle. Okay. So if the area we're trying to approximate is at least half of that, therefore the area we're trying to approximate, call that A1, is at least 9 pi over 2. So it's 9 pi over 2 plus these two areas here, small ones, plus. So if we upon find an area and find that it's less than 9 pi over 2, therefore there's something wrong with our method of approach to this problem. Okay, so let's just approximate what 9 pi over 2 will be in units. 9 times pi over it will be 14.13 minimum. 14.13 square units. Well, we do not know, okay, what it is yet, but we're just going to use that as a measure to see if we come up with something reasonable when we do the actual calculations for this. Okay, so this is what we're looking for. Now we're looking for the area. Therefore, if we take, now I'm going to draw a bigger picture of that. I'm going to go to board 2. I'm going to draw much bigger circle. I'm going to draw the x-axis and the y-axis. And I'm just going to draw the intersections and this is plus 3, minus 3. And we can actually, so whatever is bounded here, so this is the area we're looking at. I'm shading it so you would know what the limit of this area is. So we know for sure that the half of that circle, we said it was what? 14.13. Square units plus these little areas here. Okay. And this is, like I said, we're just trying to approximate at this point. What's it going to be? We're going to solve it by integration, but we're just going to approximate it right now. So if you want to find the area, now I'm going to put the equations. The area of that shaded part is equal to 1/2 integral from alpha to beta, I'll tell you what those are in a second, of R1 squared minus R2 squared d theta. Okay, so what is R1? R1 is 3 plus 3 sine theta. Three sine theta. And what's R2? R2 is 3. So the equation of the area is simply the integration of basically, if you want to call it, infinite or a small sliver here, okay, over the entire area from the bound, this bound to this bound. So what are these bounds are in terms of theta? This will be angle alpha, this will be angle beta. Okay, so it's angle alpha at 0, rotating 180 degrees to pi. Okay, so these are your bounds of your integration. So this can be written as A equals 1/2 integral from 0 to pi of what? R1 squared is 3 plus 3 sine theta squared. So we can write that down as 3 plus 3 sine theta squared okay, minus R2 squared minus 3 squared. All of that into d theta. I'm trying to squeeze d theta here. Okay. So 3 plus 3 sine theta, the whole thing squared, sorry. So it's squared minus 3 squared d theta, which is the top of the curve, which is the area bounded by the cardioid, minus the area bounded by the circle. From this point, so say from this point here, you can take that and go here to this point here. Oh, these are the bounds of integration. So now we just do the integration. It'll be A equal 1/2 times, expand this 0 to pi. This becomes A plus B squared becomes 3 squared, which is 9, plus 2AB, 2 times 3, 6 times 3, 18 sine theta, plus B squared. 3 squared is 9 sine squared theta, so plus 9 sine squared theta. Minus 3 squared minus 9. All of that into d theta. Okay. So here you have 9 and minus 9 cancel out. You're left with this term to integrate. Okay. So see if I can use another board here, but it's kind of limited in my what I can do with this board. Anyway, I'll start another board again, which I don't like, but let me see what if I can write here. So A is going to be 1/2 from 0 to pi integration limits of 18 sine theta plus 9 sine square theta. Nine sine square theta d theta. And all of this into d theta. Yeah. So I can divide this into 2, or I can just immediately find what the area would be. Area would be, this is half times 18 is 9. Integral of sine theta is minus cosine theta. So minus cosine theta from 0 to pi plus 1/2 times 9, 9 over 2, times integral of sine square theta. This comes to, so what's sine square theta equal to? In terms of trigonometric function, it'll be 1 minus cosine 2 theta over 2. You can find that in any integration book, that this will be the value. And oh yeah, we still have to integrate. So this is integral of that from 0 to pi. Okay. Make this a bit more legible. Okay. So I could write that down as A is equal to minus cosine theta from pi to 0. So this gives me 9 into cosine pi is minus 1 times minus gives you plus 1. Minus cosine 0 is 1. Minus give you minus 1. From minus 1. Plus, we're going to integrate this now. 9 over 2 times theta. So 9 over 2, so be 9 over 2 times half, give you 9 over 4. Nine over 4 d theta. This is d theta here. So 9 over 4 d theta integration will be 9 over 4 theta. And what are we integrating for? From 0 to pi. Plus 9 over 2 times half, also 9 over 4. So what is minus cosine 2 theta, the integration? It will be minus, well, integral of cosine 2 theta will be minus sine theta. So this is half, 9 over 4, and you're left with here cosine 2 theta. Integral of cosine 2 theta from 0 to pi. So we haven't integrated this part yet. Just want to make sure that you get this right. So from 0 to pi of cosine 2 theta 9 over 2 times half 9 over 4 theta 9 over 2 times half 9 over 4 minus cosine 2 theta from 0 to pi d theta. So on board 3, I'm going to write A is equal to first of all is this one here. This is 1 plus 1 is 2 times 9 is 18. Are we missing something here? Yes, 9 over 2 here. So 2 times 9, 18 over 2 equal to 9. So the first one here, this first term here is 9. Okay. The second term here is 9 pi over 4 minus 0. So it just comes to plus, this will be 9 pi over 4. Okay, so what is the third term? Well, let's just see. Integral of cosine 2 theta is nothing but minus cosine 2 theta over 2, minus sine 2 theta over 2. So it gives you, this gives you positive, will give you 9 over 4 times sine 2 theta over 2 from 0 to pi. Let's just see, 9 over 2 times 1/2 is 9 over 4. 9 over 2 again times 1/2 is 9 over 4 minus cosine 2 theta. Integration of that will be sine 2 theta over 2 times 9 over 4 from 0 to pi. But anyway, this term is going to come to 0 because sine 2 theta is sine 2 pi. Okay, so sine pi is 0 and sine 2 pi is 0. So this whole term is 0. Minus sine 2 times 0 will be sine 0. So this whole term here is 0. The only thing that you're left with is these two terms here. So the area is equal to 9 plus 9 pi over 4. And that comes to, if you take a common factor of 4, it comes to 36 plus 9 pi over 4. If we compute this, you're going to get 16.08 square units. Now let's see. We said that the half circle, which is, and I'm drawing it in magenta, that half circle here that half circle was 14, 13. So, and plus, so it's at least 14, 13, plus the areas of these are very small areas, 16.08. I would say based on approximation that this is a pretty reasonable answer. Okay, and that is your solution for this problem. Thank you very much.